about 10 to 15 minutes with no Q&A initially. We'll try and save all the questions for the end when all four panelists have had their say. So with that, I'd like to have Tareq do the first presentation. And he's with Freescale Semiconductor. He had rejoined them in 2012 as Vice President of Product Management for the Digital Networking Group, where he leads product strategy, product definition, and marketing operations. He had previously worked for LSI and AMCC, and before those companies, he was a product line manager for Freescale's PowerQuick 3 family of products, as well as a multi-core engineering design manager for Freescale's Powered PC processor group. He holds a master's degree in business administration and a master's and bachelor's in electrical engineering from the University of Texas at Austin. With that, Tareq.
Thank you, Dave. Can you hear me okay? I think it's not turned on. It's not turned on? Thank you, Dave. Good afternoon. It's good to be here. Thanks for CASPA for the invitation. I look forward to a good Q&A and dialogue with you. As Dave mentioned, I work for Freescale. Freescale is focused in providing a embedded intelligence into the network, and clearly IoT is a big part of that. My focus within Freescale is on the network infrastructure side. So not only do we participate in the IoT device side, that's the microcontroller group. My focus and what I spend most of my time is trying to figure out what kind of network is required to drive the IoT infrastructure. If I look at this from a connectivity point of view, I think Raja did a good job summarizing this, saying that sometimes advanced technology is pure magic. Right? So I see this as 3 levels of revolution in terms of connectivity. The first era was when we connected computers together. Right? I think there's a story where Steve Jobs went to Bell Labs in New Jersey and said, my vision is one day packets will come out of the wall and connect computers in different parts of the world. That was magic, and that happened. Right? The second generation was connecting people together, and that was magic. The brick cell phone that Motorola introduced has changed drastically to today's smartphones. The third era is what is upon us now, which is IoT, right? Which is connecting machine to machines. This is the 50 billion connectivity that will going to be upon us over the next few years. What will it take to do the network that's required to do these 50 billion connections? That is the $10 million question, right? There's 3 elements that have to be aligned to create this new network. Today's network is not going to be good enough for the IoT world because it was not designed to do that. It's too static. It's not agile enough. It doesn't introduce new services fast enough. So the hypothesis here is that the networking infrastructure has to evolve in a big way, introducing software-defined networking. SDN, you've heard of that term. That's number 1. Number 2, telcos have to do business differently. They have to look like the IoT, the IT guys, right? So the Ericssons of the world and the Alcatelas of the world will have to change in how they provide services. And this is, again, more of a software-centric view of the world, right? Providing services in a software form as opposed to a hardware form. And the third one is the idea of free distributed intelligence. Today's intelligence appears in the network because of the way the network was designed, right? And you can't change that. It's very static. So just taking each one of those one by one. SDN, software-defined networks, is in a way an older concept. It's been here for many, many years. However, more recently, it's been driven hard by initially academia. Stanford, not far from here, has driven papers on SDN, and the interest was in SDN only from an academic point of view. Today's conferences, when it comes to networking and networking infrastructure, is all focused on SDN. Why? Because today's networks are, again, static. Meaning, for you to rapidly deploy a new service, if there's a new application to be deployed, there has to be massive amounts of testing and reconfiguration for the old network for this new service to be introduced. That's high expense, that's high time to market. That has to change, and that's what SDN provides us. It's still early days, right? All the existing companies, the Cisco's of the world, the newer players are having to figure out what SDN really means and how it can be deployed and what the use cases really look like. The second one is the network function virtualization. Okay, so this is the second trend, the second element that needs to be there for the IoT infrastructure. It has to do with the guys that do telcos who had numerous number of infrastructure, a lot of different hardware platforms that didn't communicate with each other. They're trying to really harmonize that and bring that to market in an economically possible way, right? And that's what NFV is. It's driven by ITSI. ITSI is basically a collection of European telco guys, the service operators, trying to come up with ways where a software-based networking services will be the focus for the future. The third element is what I call redistributed intelligence. Again, here the idea is the old network, today's network, is very much designed in an old-fashionable way where intelligence is fixed and can't be moved, right? And that has to change because ultimately the application needs to determine where the intelligence needs to live in the network, whether it's in the edge, at the actual premise, or in the core of the cloud. Right? So examples here are, if you have an application that's latency sensitive, if you're doing voice, you must be able to do the intelligence locally. You can't wait for the cloud to back that up for you. If your service is latency tolerant, right? Let's say if you're doing a firewall application, intrusion detection, maybe you can have the cloud be the one where intelligence is living. Right? That's where the processing, the CPU horsepower is taking place. And ultimately, the third picture there is the hybrid. There are cases where you will have a little bit of both intelligence available, where let's say you're doing video caching is a good example. If you're doing video streaming, the video is maybe living on a processor, media server is living in a processor in the core network, but there are cached versions of that video around the edge. And why is that? Well, that improves the latency and improves the bandwidth utilization of the network. So, what are we saying? What we're saying is the new world, whether it's IoT, Cloud RAN, mobile, 5G, has to be built on this new network. And this new network has the three different elements we discussed earlier. IoT, again, is going to make use of the massive number of connected devices. Okay. Now this is a signaling game, not just a bandwidth game. Okay, so if your network is focused on heavy signaling traffic versus just pure data traffic, it has to change, and that's the change that will be required. Cloud RAN, this is the idea of centralizing baseband in the base station and putting that in a large central office base station as opposed to having macro base stations distributed around the world. And then the last one is the idea of having 5G. And what we're seeing in 5G is, it's still year 2020 before 5G is required, but 5G is all about the services. And how do you do machine to machine? And how do you take care of signaling? It's less about bandwidth, which is what 4G was all about. Okay, my last slide here is what does this really mean to the value chain? It really means a big change will be upon us. Okay, so if you look at today's value chain at the top, it's going to evolve and change to something similar to the bottom picture. So if you look at the service providers, right, today there's primarily business people, right, the enterprise and the telco. So there's AT&T, there's Sprint, China Mobile on the right side, and then there is the enterprise, American Airlines buying equipment. What will happen to these guys? Well, for sure, the guys that are buying networking gear in the enterprise, they're now re-evaluating how they spend their money. They would be likely spending more money on cloud services. They would go to Google or Amazon so that they can get their CPU farm, they can get their networking done, offloaded in a services environment as opposed to actually buying gear from the likes of Cisco and Juniper. So clearly, the web services guys and the cloud services guys will grow. If you look at the OEM side, so today we have IT-centric OEMs, HP, Dell, and there are telco-centric OEMs. So that's Alcatel-Lucent, Ericsson, Huawei, ZTE. These guys are also pressured to change. They will be, the IT guys are trying to do more networking telco things. The telco guys are trying to get to the networking guys' domains. So there's going to be a hybrid OEM that will be selling not just to the IT world, but to the telco world. What will that mean and how does that change? That's going to be very interesting to see. And then from a semiconductor provider point of view, something like Freescale, okay, the world is going to change, and that's why we're seeing a focus on more open ecosystems. So having an ARM ISA is going to be key. Having Linux, having KVM, these are all open standards that will be driving this new next generation networks. It's going to be focused on moving laterally, having to make sure that you have a multi-core piece, having the switch element, the Wi-Fi connectivity piece, and the semiconductor player. But also semiconductor players have to do more in software, providing more value up and down the value chain. There's going to be also probably less focus on ASIC solutions. People will find ASICs to be too expensive to focus, to invest in. That's why we're seeing fewer and fewer ASIC players, and more focus on standard solutions type solutions. So that's my summary. The world will change, and the networking infrastructure that's needed to drive the new world will have to be in place 3 to 5 years from now to make this new magic take place going forward.